Imagine a vast symphony played by a massive orchestra, with an uncountable number of stars, planets, and moons all joining together in perfect harmony. Yet within this grand cosmic performance, there is one area that has perplexed scientists for years: exoplanets. Exoplanets are planets located beyond our solar system, hidden somewhere deep within the Milky Way galaxy. You might be amazed to learn that some of these exoplanets share remarkable similarities with Earth, creating an intriguing possibility. This discovery opens the door to something twisted, like a scene out of a captivating science fiction saga. Researchers using the James Webb Space Telescope made an unexpected finding from Proxima b, uncovering a peculiar signal so complex and structured that it sparked widespread debates across scientific circles and social media. Dubbed a potential text signature, the signal was an electromagnetic emission so sophisticated that it suggested the possibility of an advanced civilization residing in the area. Humanity's collective excitement reached a peak, as this discovery threatened to revolutionize how we perceive our existence. Could this be the long-awaited proof that we are not alone in the universe? However, just as mysteriously as it appeared, the signal faded away, leaving behind a haunting silence and a web of unanswered questions and emerging theories. Was this merely a fleeting cosmic event, a random alignment of celestial bodies? Or could it have been a deliberate message, an indication of a distant, unknown presence? This singular event cast a shadow over Proxima b, prompting a flood of speculation and curiosity. Was it an anomaly, or is there a much deeper story waiting to unfold? But the cosmic story doesn't end here. The ink on this narrative is still fresh, and new chapters are being written. This time, it's not just the usual scientists, but renowned Harvard experts leading a shift in how we approach the search for alien life. Their research goes beyond analyzing signals and anomalies we've already detected. They've expanded the search by turning the James Webb Space Telescope into an enormous night vision device, designed to detect artificial light sources across both dark and illuminated regions of distant worlds. One exciting possibility under investigation involves detecting Earth-like urban environments glowing like radiant cities in the vast dark of space, shining across the endless ocean of the cosmos. As we continue to unravel the mysteries of the universe, the search for extraterrestrial life is becoming more profound than ever. This effort transcends the intrigue surrounding Proxima b and delves deep into the far reaches of space, fueled not just by new technologies but by an insatiable curiosity about our role in the universe. Ongoing advancements in cosmology and space exploration have already identified numerous exoplanets that could harbor life. Tools like the James Webb Space Telescope, JWST, and ground-based observatories are significantly enhancing our ability to detect and study these distant planets. One particularly exciting field of research is the search for biosignatures, signs of life. These could include atmospheric gases like methane or carbon dioxide, which, under certain conditions, suggest biological processes. The JWST goes far beyond simple detection. With its advanced instruments, it is capable of precisely measuring an exoplanet's atmosphere. By studying the starlight filtering through an exoplanet's atmosphere, scientists can identify chemical markers that indicate the presence of life. For example, finding water vapor alongside oxygen or ozone could point to conditions that support life. Another promising avenue of investigation is the search for technosignatures, traces of advanced civilizations detectable through their technologies or artificial structures. These may appear as megastructures, such as Dyson spheres designed to capture the energy of stars, or as strange radio signals. Beyond technology, the search for life also hinges on international cooperation. Collaborative efforts between space agencies, research institutions, and private enterprises are crucial to advancing our ability to explore space. Missions to Mars and other celestial bodies, for instance, rely on pooling global resources and expertise to achieve shared goals. Public engagement and education are also vital, sparking interest in space science and encouraging future generations to pursue careers in STEM fields. Technological advancements are key to deepening our understanding of the universe. Improvements in telescope design, data processing, and computational modeling have enhanced our ability to study faraway exoplanets. New space telescopes, like the Extremely Large Telescope, ELT, and the Habitable Exoplanet Observatory, HABX, will soon offer even greater observational capabilities, providing more detailed insights into the habitability of distant worlds. Each new discovery brings fresh questions and opens new areas for exploration. The search for extraterrestrial life isn't just about discovering alien civilizations. It's about understanding the origins and diversity of life across the cosmos. This pursuit challenges our worldview and helps us learn more about what it means to be alive. In conclusion, the study of exoplanets and the search for alien life is a dynamic and evolving field. Each advancement brings us closer to answering some of humanity's deepest questions. As we push forward in our exploration of the universe, the possibilities of discovering new forms of life and understanding our place in the cosmos seem limitless and tantalizingly close. Proxima b, a potential twin of Earth just 4.2 light-years away, stands as one of the most fascinating puzzles of our time. The James Webb Space Telescope is transforming how we search for extraterrestrial life, opening up new understandings of these cosmic mysteries. Picture a moment when your thoughts drift across the immense vastness of the Milky Way, home to a mind-boggling number of exoplanets, more than a quadrillion. That's a 1 followed by 15 zeros. To visualize this, imagine that each of these planets was the size of a grain of sand. This would be enough to fill the Grand Canyon, and then create another version of it stretching across an immense distance. What's particularly astonishing is that about 20% of these planets have been identified as Earth-like in terms of geography and environmental conditions. This means there's a 1 in 5 chance of finding an Earth-like twin in the universe. The story doesn't stop here. Alongside these exoplanets, there may be another quadrillion moons, rocky satellites orbiting their parent planets, locked in gravitational motion. The universe offers an endless array of possibilities for discovering worlds that could support life, or may one day be capable of doing so. Now that we understand the magnitude of this vast expanse, let's turn our attention to the true key player, the James Webb Space Telescope. This extraordinary instrument, with its impressive focal length and adjustable lenses, surpasses even the most advanced optical technology. It boasts a 6.5-meter primary mirror, 2.7 times larger than Hubble's, offering unmatched clarity even when observing the faintest stars billions of light-years away. The true brilliance of the JWST lies not just in its observational power but in its advanced technology, including state-of-the-art sensors and spectrographs. These tools do more than just observe. They analyze the light emitted or reflected by celestial bodies, revealing details about their atmospheres, compositions, densities, and even their masses. The JWST can determine whether a planet has essential elements for life, such as water, organic compounds, or even oxygen. In essence, it isn't just a telescope, it's an analytical powerhouse. It marks a massive leap forward from Hubble's capabilities, offering an entirely new perspective on the universe. If Hubble's discoveries amazed you, prepare for an explosion of revelations as the JWST expands our view of the cosmos. One star in particular has drawn considerable attention, Proxima b. Since its discovery in 2016, this mysterious planet has captured the fascination of astronomers and astrobiologists, mainly due to its potential to help answer profound questions. Why all the attention? Proxima b is extremely close to Earth, just 4.22 light-years away. To put this into perspective, if you could travel at the speed of light, it would take just over 4 years to reach Proxima b, roughly the same time it takes for a TV show to rerun its episodes. In a universe that stretches more than 93 billion light-years across, discovering a planet so near and ripe for scientific exploration is like finding a rare gem in a pile the size of Mount Everest. Proxima b, in its proximity and mystery, may hold the answers to questions about life itself within the vast cosmic web.